thank you, Giancarlo, for having me here. So I'm a computational logician, so that's my role. So I'm no philosopher, I'm no linguist, I'm no computer scientist. But my role is the guy that tries to fill the gap between all these areas. In this sense, nobody really recognizes me. So philosophers say I don't understand anything, computer science say I don't understand anything, logicians say I don't understand anything. So I'm really humbly here and try to add this keyword to this picture. And to let's say, I'll try to provoke today to clean up the mess that you are doing. So at the beginning, I will talk about something I don't know anything about, which is this formal ontology stuff. That's these two guys that apparently have a major role, but I never met them. All the other guys I'm going to talk about, I've met them, some of them are here. So basically, my starting point is to observe what other people have done, what other people are saying. And there is this very interesting issue. Well, I'm a PR person, so really, this ontological level, epistemological level, I met for the first time the stuff by Nicola in 1985. He did not know me, but I actually did download some of his code about the ontological level, whatever it was at the time. And so I really have been already interested to see what other people are saying and try to understand it. And to me, understanding means to find a connection with a formal meaning. And the formal meaning is not just something which is a mathematical structure, is how these things relate to the actual word that we want to say. So representation is a linguistic phenomenon, as a syntactic element that actually is meant to represent something in the real world. So this bridge is what logic is about, which is syntax semantics. So somehow syntax semantics, as Nicola was saying, is it's just taken at the logical level, is just not interesting for this audience. But using this tool to formalize whatever is can be built on top of it is probably interesting bit. And the important bit is to do it properly. So what I understand about formal ontology is that you try to find the right categories and to formalize the categories of the word. And when these entities exist or don't exist, and basically what you do is you make these theories, foundational theories that tell how to distinguish the notion of redness from the notion of dog. Okay, fine. And you're not even able to agree among yourself. That's fine. I really like that. But that's fine. That's exactly the challenge, because everybody can see the word the way it wants. Then you discuss, and then of course the point is at some point you have to be clear as much as, okay, I don't mean this, you mean that. Fine, you have different views of the word, but at least we understand in which level we differ. And that's why people probably at some point want to use logic. Indeed, these communities are my three mentors, right? So Achille is not here, but Nicola and Giancarlo. So Achille I met for the first time in 1988. And so it's a really long time friends. I actually, the first time I met Giancarlo was at a seminar in Trento, mid-90s, something like this. And I really say, well, this is the right guy, because, you know, this community really is too scrappy. And I saw in him somebody who could be less scrappy than anybody else. Okay, just forgive me my sleep role. Okay, so, but now these guys use logic. But use logic in a, I try to understand how they use logic. So they write this very complex axiom. In a multimodal, multidimensional logic, they use cryptic structure, they use all sort of topology, mereology, algebras, which is fine. But they did not really know that what they were doing. In the sense, when I say, well, I want to formalize these categories, and I relate to these structures, there was a confusion we discussed yesterday with Nicola while strolling in the Dutch countryside. To me, there is a confusion when I want to say, well, these are the important things that relate this object, these categories. And these categories belong to some predefined structure, mereology, topology, or whatever. And they have all this bunch of axioms that somehow mix these two aspects. The aspects about what makes a difference between a row and a kind, and what is notion of part of, non-overlapping, whatever. So these two things are just in a big, gigantic pot, which I believe does not help. So at least methodologically, whenever I was trying to read these things was, okay, they're talking about particular mathematical structure, the notion of time, total order. And then, of course, in this time, we have this notion of events of this kind, events perdurant, endurant, whatever you're calling this now. I stopped reading all these things. What can I do? So much time. Okay, so I want to abstract this field to say, well, these are first order theories over categories, and these categories make use of this complex mathematical structure, which should be there. Okay, and these are these two layers, right? So this is the way I would use this logic. So basically, I will come back to this at the end. So this is what, to me, should be the role of this formal ontologies, to just focus on this first order part of this characterization of things, what makes things different, how these categories are characterized, and not focus on which is the mathematical structure behind it. However, these guys brought tons of axioms. So I mean, this is I guess this is the book of Achille, the first book, and that's Nicola in Ontocline, I guess. And right, so at some point, people started writing axioms about what a merology is, what a topology is, what time is, what means overlapping. And then this is confusing with what is the essence of meaning of kinds and categories that you want to characterize. And moreover, nobody really understands what these axioms are for. In the sense, really, they are, that's unlikely what eventually I understood. These axioms are really trying to axiomatize the structures that you want to happen in your formalization. So you axiomatize parthood, you axiomatize stuff. So, and you don't, and you do it in a classical logic, okay? As opposed to use a logic which has, in the semantic structure, this merological structure, this topological structure, these algebras, etc. And moreover, by doing this, you don't really know what you're doing, because is this really behaving like a proper topology? Well, then people started to, so because of this approach, well, at least let's check if whatever I write makes sense, in the sense it's at least consistent. Okay, well, yes, thank you very much. It's consistent, but then is this really capturing what you want? On the other hand, I think this is where people should actually focus. Use your axiom to tell exactly what you want, assume that there are things behind, and somehow use this axiom to explain what you are, what you mean for this property to be. And okay, so this is yet another proper part, overlap, whatever, all these things which, so, and this is the point. So take merology, or take, I've seen a recent paper in Carlo, where he formalized Allen's algebra, right? And it's not even correct. So in the sense, it's just an approximation. Why you want to approximate? It's just there. Just use it. It's an algebra. It's there. And actually, there are logic that can make use of this algebra very, very easy and computationally viable, etc. So, but even so, the point is, when you have these axioms, what are you really capturing? Of course, this axiom per se tells something meaningful. Okay, I have a weak supplementation. Fine, I understand this. I want in the word this action to hold. And that's exactly what I believe people should focus on, not in defining overlapping. These are two different kind of axioms. And because I want to have a word which behaves in this way, which is in this way, is set theoretical, is numerological, it has this property, has this time, it's structured in this way. I have fiat boundaries, I don't have fiat boundaries, all these things are just in the semantics. But then in this word, I claim that these other properties hold. weak supplementation. And that's what I want you to focus on. Okay, not on set theory. And because otherwise, you never know what these axioms are actually saying, how they interact, what they entail. Well, the only thing you actually know is that probably they are consistent, if at all, because sometimes people start discovering, okay, maybe this axiom they didn't realize not even consistent. So this is a discussion we had yesterday with Nicola. I had this nice slide. So basically, the connection between this notion of axiomatizing, of clarifying, whatever you want to say in logic, is well explained by this very old picture by Nicola. It appears in most of his slides, where it says, well, what we want to do with my logical axiomatization is to capture the intended models, right? So that the models of my formal theory more try to capture at best the intended models that I actually intend to do capture. This is clearly, I would say, in general, an attempt bound to fail, in the sense, what are the intended models? The only thing that you know is that, well, all the models I have in mind have to have weak supplementation. All the models I have in mind should be such that the kinds have this truth-making criterion and all these things and so on and so forth. But you don't really know all these intended models. And you don't, when you formalize them, when you formalize your intuition of these intended models, these axioms, you don't know how these axioms actually interact among each other by generating unwanted models. So this approximation is something that is really, yes, it's a nice, it's what you really want to achieve, but it's not clear how to achieve it using logic. I don't want to spend more time on this. Okay, so at this point, why are we all using logic eventually? In my idea, it's because we want to clarify what we do. Okay, so let's focus on the fact that we want to clarify what we do. But on the other hand, there has been a strain of research that, okay, we use logic also because we want to have implementation, whatever this means, because logic can be implemented, they can reason with them, and they can do stuff with them. And people were concerned in this community that, okay, I'm using these very complex logics. And first order logic, multimodal, multidimensional, in principle, even though eventually they are actually just first order logic with a lot of axioms. Again, I prefer to see this as first order logic over a multitude of theories behind, of model theories behind. So this multidimensional idea. But the concern about this, the community was, okay, there is a pressure. I want to get funding, so I have to build a system. I have to do something for the real world. I have to build AutoUML. Fine, that's cool. But my formalization is useless, apart from being a little bit messy, but it's also useless because it's very complex and it's definitely undecidable. I can use any tool to do that, to implement my logics. Well, this is, of course, true up to a certain point, because, of course, there is a whole family of theorem provers, which now is very efficient, and if guided by humans, they can do a lot of interesting stuff. Of course, you cannot pretend to give a theorem prover to a software engineer like you give it onto UML, so that's clearly a direction that, for example, Giancarlo did not want to take. But just for the sake of theory, we have to know that, according to my suggestion, that now the formalization in logic should be done in this just very simple first order logic with a lot of complex model theories. Nowadays, there is a very popular way of having theorem provers, which is a disability modulo theory. So you have a first order logic where you can attach your algebra, your topology, your whatever thing you want to concrete domains behind, so that the reasoner, of course, driven by humans, can be done over this mathematical structure. So you don't need to axiomatize neurology, first order logic, but you can actually assume that it's just there in a theory behind your theorem. Still, this is not a push button technology, so let's focus on the model of the fragments of first order logic that people at some point looked at, because, well, as Nicola was showing, from how traditionally this community also comes from the KR, the description logic community, so they found a natural goal to end up into a decidable fragment, for example, description logics. And so now these are two other mentors of mine. This is Andrei Vorankov with his Hebron Award of 2 years ago. and is really the strongest person in the world about theory proving. This is Ian Pratt-Hartman, who is the greatest guy in the world. He wrote this book just published a few weeks ago. Is the guy that knows everything about decidable fragments of personal logic. So if you want to look at fragments that may be decidable with theorems and with your algorithmics that work for the fragment, and you want to look for a very specific thing which does not capture the description logic, you go to this book, you go to the appropriate chapter, and then you see that this may be useful for you if you want to go this route. Okay, so now we are in this notion of computation. So you have to use a fragment of personal logic because we want to have a decidability, and decidability is important if you want to go there. And again, we had discussion yesterday. So when you have, if you want to use a logical theory in computer science, embedded in a computational system, well, that's an embedded system. So you have a black box, which has your formal ontology, your logic, and then you want to use it, I don't know, in a software engineering environment, you want to use it like we do, for example, for satellite launches at the European Space Agency. You have these things that actually play a core role in a much larger system. So if you access your ontological formalization of your domain to take decision, then you really want a sound and complete system and for decidable system, terminated system in your black box, because your decision may depend on positive and negative answers. So if the system is just sound, which is the only thing that basically more or less weekly is guaranteed by this community, then this is just not working. That's probably why this community wanted to go into these decidable fragments, where you really want to have now a sound and complete algorithm for a weakly sound theory. That's my, that I would go back in a sec. But somehow, okay, a critique, okay, we are using this very strong approach and we use this with a very weak approximation of my theories, which are already weak approximation of what I believe reality is. So that's an interesting chain of events. Okay, the point is that now which fragments, again, even though I come from the description logic community, I really try to be much more open-minded. There's plenty of fragments which are decidable, which may actually be useful for the community in general. And I really like this unpacking a thing that Nicola was mentioning in this last slide. I mostly disagree with what Nicola was trying, and the way Nicola was trying to explain these things, but that's interesting because we have to talk about it and we have to go on this topic. We have a PhD scholarship open, it's going to be open until mid-August. So if you want to work on the last slide of Nicola with me, Nicola, and Giancarlo, once the scholarship fully paid in Bolzano is available. Okay, the point is this one. Why we want to have this formalization? Okay. I think that what this community has lost is why you want to go down this road. So why you want to, which kind of reasoning task are you interested in? Is there any difference between a reasoning task and decidability in general? Well, there's no difference. When you have a logic, you have to buy it as a whole, right? So this entailment, a classical entailment, it's not that you can decide as a logic, I want to do this and not that. You have to buy it as a whole. So all these questions typically are questions that you have to ask yourself because taking a particular route, including one of complexity. And somehow this has been taken for granted. This community, well, let's go description logic is popular, is fashionable, there is a lot of publication to be done there. Okay, so description logics, already mentioned Ron Brackman, another friend of mine, Hector Levesque from Toronto. And well, he comes more from the philosophical side. He was a linguist in his PhD with Hoods, and Hector was actually his PhD student at the time.
With John.
With John, right, with John. And so he was a logician, and in fact, this is Hector pushed for this idea to give up the ontological meaning, which is interesting. I think I found that moment positive, not negative, like you were saying, because he said, well, if they give up, I have more space for myself to get in. So, because I also found this interesting, but not in a negative sense, but for me in a positive sense. Let's do that. Let's try to understand. There is a difference. Why is that? Right? And these guys, they gave up. So they studied a number of properties that this logic had, which made this logic very popular because they're very implementable. They actually, because of Ron, they were born to be, I think a strong word, isomorphic, to mirror the way we currently store our information about the world. So genus and difference, right? So that's what we do. And that was technological experiments that were done in the 60s, etc. So the kind of epistemological primitives that description logic gave, and before the else, there was scale 1, which was really the cognitively motivated language, which was then formalized by Hector. So this epistemological level is really mirroring the way we actually organize information. That's why they are so potent, popular, and powerful. And if you think about modeling languages all around the world, coming from all possible disciplines, from engineering, computer science, modeling, so you can take UML, ER, ArcMate, and all the kind of diagrams that engineers do, they all capture this idea, right, of classes and properties, entities and features. And of course, then we realize these are just isomorphic to model logics. So then we entered this field, and then we forgot why we were there. But not me. In fact, these guys don't believe that I'm an interesting guy because I'm not doing whatever they want. So now we have a nice logic, which is decidable. We can do stuff with it. And what you should not do is what I'm seeing around here. Use this logic to embed all these horrible axioms that you have found pages and pages of. And so you should not write this axiom in DS. DS is the way to write your own applied theories that make use of the categories that you have formalized before that belong to the semantic space. Okay? It's just plain wrong to try to pack everything in description logic. In fact, it does not work. And I read it in a very recent paper of Giancarlo that is, if I define, okay, we did that, does not work. Okay? So, inadequacy of description logic for the specification of comprehensive foundational ontologies. Then I asked ChatGPT. Now, there is no talk without ChatGPT mentioned. And indeed, it's interesting because when I asked ChatGPT why Nicola and Giancarlo, they're somehow different personalities and focuses are similar, because they both believe in logic, in capturing and representing knowledge, this enables precise and unambiguous definition of concept, relationship, and constraints, ensuring coherence, consistent, and effective reasoning capabilities. This is what you are lost. So you're not doing this anymore. Okay? Even ChatGPT knows that. You have this goal, but ChatGPT, being an hallucinating bullshit generator, maybe you don't really believe that. Okay, so what I believe this should be, how should be done. This is sort of dream. That's another friend of mine, the co-creator of Ontology. And right, these are all Ontology stuff. Now, take a logic, maybe description logic or any fragment you like, embed in the semantics all the structure, the algebra that you want. In particular, we can do that in description logic. It's plenty of work where you can have time, space, topology, mereology, Allens, whatever you want is there. You have to forget that. Whenever you have a particular predicate that belongs to the space, this is just behaving the right way. And then use this logic to actually focus on the aspect you want to emphasize that makes, okay, I, Nicola, believe this reality behaves this way, while you behave in this way because we have this different experimentation. Let's focus on that. That's what I believe should be done. In particular, it could be done also in first order, but if you want then to reason about that, you can do this in that. And okay, so this is one way. Okay. Sorry, I skipped one slide indeed for this one, because this is another important guy, Carsten Lutz. He is the most important guy in description logic. He is the one that actually is studying all this logic where all these algebras and mathematical structure can be embedded in the model theory. And the logic being decidable. So many extension description logics are fragments of multidimensional, multimodal logic. This means that the semantics is embedded in the model theory. I can have time, space, topology, mereology, various algebra that are in the model theory, and they are decidable. They are description logic, so I can do many interesting things from the point of view of the epistemological level. But I don't have to care about the fact that I'm talking about a particular mereology or a particular algebra that I'm interested in that may be different from the one that Nicola is using, and so on and so forth. So we don't have schematization of this stuff. It's just embedded, it's just pushed in the model theory. And it works because eventually we have a simple language, which is a DL language, but it's simple, but it's effective because, again, as this mirrors our cognition. And I can have simple, I can work also because I can have simplification over the mathematical structure I want to have. And eventually this, and you are given, you can download from the web your reasoner for this particular logic. Carsten, thank you. Now, once we have this, we can use this approach to write, I was saying, to write our foundational ontology and our applied ontologies, just forgetting about all these small details. Or, which is the thing we actually do prefer, is to forget about all this. Sit down and on paper, prove the properties that these particular mathematical choices entail. I take the example of OntoClean, right? OntoClean has this kind of axioms where they completely neglect the fact that rigid type has a particular mathematical or formal definition. It's an answer to a competence question. So humans decide and make the reasoning about, is this a kind, is this a role, is this an endurance, or whatever you're calling it now. Note the critic. Now stop changing names to stuff, or at least agree on it, right? I'm confused. Okay, so have these questions and build up a reasoning pattern that is provably correct with respect to what these things actually mean on paper. Okay, so the logic does not implement what the region means. Yes, I have 2 minutes. The logic does not implement what these categories mean, and but you actually can on paper prove that because of this meaning, the kind of reasoning patterns have to behave in this way. That's exactly the idea of OntoClean, which I suggest to generalize as much as possible for the real world. Okay, so these are things to learn about, more about description logics, but it's not really interesting. And then it is actually just not the last slide.